So here's a circle. How many degrees to go around the full circle? 360. That means if I only go around half the circle, how many degrees is that? 180. Now, in radian, how many pi is the full circle? 2 pi. So if I only go half the circle, it's 1 pi. That is what you should carry with you all the time. That 180 degrees and pi are exactly the same. Okay, so now this is a crash course in trig, remember. So we're gonna, be using a lot of, okay, bottom line, what are we doing? So it's pi and 180. With that, you can convert between radian and degrees. Because whatever degree measure you have, okay? So suppose it's, 312 degrees. The conversion is that pi and 180 are the same. So I always do times and a fraction bar. Degrees are on top. They go on the bottom here. That just leaves one place for the radian. Now, are you ever going to run into 312 degrees in calculus? Not really. Normally, we deal in calculus with the special angles, and even better, most of the time they're in the first quadrant, and sometimes they will be outside of the first quadrant, okay? So, but that's how you would convert. Now, if you have, let's say, 3 pi over 7, again, I do times and a fraction bar, and my go-to conversion is pi and 180 are related. So if pi is on top, now pi goes on the bottom, and I only have one place to put my 180. I do a little bit of canceling, I do a little bit of calculating, and I get the measure in degrees. Okay, now, unit circle. I know you hear unit circle and you just want to run out the door. But if you make friends with it, then really it's the best tool you will have. Now, here is what I do not want. In fact, I don't even want to see this. I do not want people memorizing the unit circle. We don't do that because it's useless, because you forget and then you don't know how to do it. So I don't even want to see you guys attempting to memorize the unit circle. All right? It slows you down. It's not good. Now, what we're going to do is this. I'm going to go from the very basics and on up. Now, back in geometry, you learn about this thing called a special triangle. And there are two special triangles. One is the 30, 60, 90. And the other one, we always say, is the 45, 45, 90. Okay? Now, in the 30, 60, 90, you have a hypotenuse, and then there are two legs. Are those two legs in the 30, 60, 90 congruent? No, one is shorter, one is longer. Now, the one that faces the 30 is the short leg. And just for fun, I'm going to give it a size of 1. The long leg, which faces the 60, is always root 3 times bigger than the shorter one. So that becomes root 3. The hypotenuse is always twice the short leg. Okay? That's that. Now, for the 45, 45, 90, it's even simpler because the two legs are congruent. And let's just say they're both equal to 1. And the hypotenuse is always root 2 times one of the legs. Okay, that's all fine and nice, but that was geometry. Then we get to real actual trig, and it's all about the unit circle. And the reason why the unit circle is called the unit circle is what? It's got a radius of how much? 360. It's got a radius of 1. Okay? The unit circle has a radius of 1. That means if I'm at the center of the unit circle and I go out, that's a distance of 1. This is a distance of 1 as well because that's a radius, right? So let's just focus on that blue line. That's a radius. How big is that? 1. Okay. I just said, okay, so now this triangle has a hypotenuse of 2. If I were to try to draw that triangle in this unit circle, it won't fit because the hypotenuse is what's going to be the radius. Is that right? So look, this is an angle of 30 degrees. That's an angle of 60 over there. But the hypotenuse I'm constricted to having it be 1 unit. So how can I fit a triangle in there with a hypotenuse of 2? That's just impossible. So what I have to do is just like you do on Photoshop, I need to scale down my triangle so that the hypotenuse isn't 2, but it's 1. Well, what can I do to a length of 2? What can I divide it by in order to make it a 1? I can divide it by 2. But it's just like I was doing it on Photoshop and doing it proportionally. So all the dimensions have to be divided by 2. So I divide this by 2 and I divide that by 2. And now magically, that triangle, 1, root 3, and 2, disappears. Now I have a brand new triangle. And the units and the sides are just 1/2 root 3 over 2. And from this moment on, that other triangle is dead to us. Okay? So I have 2 legs, a short one and a long one, and they're always only going to have lengths of 1/2 and root 3 over 2. So here, it's 1/2 and root 3 over 2. Okay? Now, if I wanted to find the sine of that angle, back in geometry, we define sine as being what over what? Opposite over hypotenuse. Okay, that's just baby language, right? What I take from that is that the sine is always going to be this vertical side on the unit circle, and the cosine is always going to be the horizontal side. So if I have a 30-degree angle that faces the smaller leg of 1/2, that must be the sine, this vertical. So this horizontal is the cosine of root 3 over 2. Okay? Now, that might still be a little bit confusing to us. So why don't we take another angle? Why don't we take an angle of 60 degrees? So look, I'm going to draw the angle of 60 degrees. That's right there, right? Let me take the triangle here. There are 2 legs. Is the vertical one the longer or the shorter? The longer. So what's the length of it? Root 3 over 2. And this is 1/2. So there is only 1/2 and root 3 over 2. Only 1/2 and root 3 over 2. So now if I wanted the sine of 60, here's how I, Miss Malikian, do it. Sine of 60. Okay, 60 is the larger angle, faces the larger side of root 3 over 2. That vertical side is always sine, so it's root 3 over 2. And what if somebody asks me for the cosine of 60? I say, okay, 60 faces the larger side, so this must be the smaller 1/2. That's the cosine. Okay? Now, what about the 45, 45, 90? Again, I need to make that hypotenuse a 1. So I divide by root 2 all over. So now, if I draw that again, I have 1, root 2 over 2, root 2 over 2. So if I were to draw a 45-degree angle, the 2 legs are only ever root 2 over 2, root 2 over 2. So here's a question for you. What's cosine of 45? That's the flat side, horizontal, root 2 over 2. What's the sine of 45? Root 2 over 2. Okay? Now, one other thing we need to know about this is in each quadrant, SIGN, sign is different, right? So in the first quadrant, what functions are positive? All are positive. Here, what functions are positive in the second quadrant? Just sine. And the third quadrant, tangent, and here, cosine. Okay. And now you guys are, and now finally that statement is true, right? You guys are officially like all students now, right? Okay. So evaluate each of the following without a calculator, no decimals. Okay. So again, here's how I, Miss Malikian, will do this. So, remember how we talked about 30 degrees and 60 degrees? What are their radian equivalents? pi over 6 and pi over 3. So if you see pi over, okay, so here's how I, Miss Malikian, will do this. Sine of pi over 3. I say to myself, okay, pi over 3, that's the longer side, that's the largest angle. Faces the larger side, that's root 3 over 2. And since sine is always this vertical one, this is root 3 over 2. Okay? Now, next, cosine of 3 pi over 4. Now, let's just see what quadrant that belongs in. 3 pi over 4 is 3/4 of a pi. So if it's pi all the way here, how much is 3/4? Which quadrant would that fall in? The second quadrant. So cosine is negative there. Now, 3 pi over 4 is like pi over 4, which is like how many degrees? 45. And what are the two legs for 45? Root 2 over 2. So whether it's sine or cosine, root 2 over 2. And you'll find that when I'm talking, I instinctively gesture sine and cosine, sine and cosine. And I do that on purpose. So you always just see sine and cosine. And eventually, I want you to like visualize vertical as sine, horizontal as cosine. Let's skip C for a minute. Let's do D. 5 pi over 6. What quadrant is it? Second, I hear. This is 5/6 of a pi. It's just short of a full pi, so second quadrant. Is sine positive or negative there? Positive, because it's all students, sine. Pi over 6. Larger angle, smaller angle? Smaller angle. Faces 1/2. So what's the sign? 1/2. Positive 1/2. What's the cosine of that then? Root 3 over 2. Okay, let's still skipping C. Let's go to E. 4 pi over 3 is 4/3 pi, which is 1 1/3 pi. So it's the third quadrant here. Secant is like cosine. Is it positive or negative there? Negative. Now, if secant messes you up, think of cosine. What's the cosine of a pi over 3? Pi over 3 is the larger one, so this must be 1/2. So secant is 2, negative 2. 5 pi over 4, that's 1 1/4 pi. What quadrant? Third. That's positive. Okay, now I got cotangent. So cotangent compares the horizontal with the vertical. Horizontal with the vertical. For a pi over 4, how do the lengths of horizontal and vertical compare? They're the same, so what's the ratio? 1. So cotangent of pi over 4 is 1. Here's a trick question. What's tangent of pi over 4? Also 1. Not a trick question, lying. Okay, question. While I answer some questions, I want you guys to go and do G and H. How much? How much is cosine of negative pi over 3? I have a 1/2. Whoa. Okay, so which quadrant is that in? Fourth quadrant, so cosine is positive. Now, so if it's pi over 3, it faces the long side, root 3 over 2, that's the sine. This is the cosine, horizontal, 1/2. Now, negative pi over 4. That quadrant. Okay, now, for negative pi over 4, let me just draw that angle here. This is negative pi over 4. Okay? How big are the legs? Right, so root 2 over 2, root 2 over 2. Tangent compares the opposite and the adjacent, so this is negative 1. Yes, sine over cosine. Right. Okay. Yeah.
Whenever the letter F, if the answer say, I can't read what that says.
F says positive 1.
Positive 1. Negative 1 with a line.
Huh?
Looks like a negative. I didn't realize that was a plus sign.
Right. Okay. So let's go to J. I'm skipping some on purpose. Let's go to J. What quadrant are we in? The second. So cotangent over there is negative. Now, it's a pi over 3. That's the larger angle. So the sine is how much for that one? The sine is root 3 over 2. How much is the cosine? 1/2. Okay, so cotangent is cosine over sine. 1/2 over root 3 over 2. Now, anytime you've got the same denominator on top and the bottom, they just go away. So I have 1 over root 3, negative root 3 over 3. Okay? Yes. Right. Yes.
I thought negative 1 over root 3 is the tangent and
the tangent would be root 3. The tangent of this is root 3. Okay. So 11 pi over 6 is 1 and 5 over 6 pi. So in what quadrant is that in? Fourth. Secant is like cosine. Is it positive or negative there? Positive. Now, secant is the reciprocal of the cosine. So let's talk about cosine of pi over 6. Pi over 6 is the smaller angle, faces the smaller side. So the cosine, which is the horizontal, will be root 3 over 2. Okay, so pi over 6 is the small angle, faces the small side. So this is 1/2, this is root 3 over 2. All right? Cosine is root 3 over 2, so secant is 2 over root 3. Right. Okay, now we're going to talk about quadrantal angles. If an angle is not in the interior region of the quadrant, if it's on one of the x or y axes, we call it a quadrantal angle. And the reason why I left those for later, and I'm going to do them in a different color, is when they fall on the x or y axis, you're going to do a different process. So look, pi, where does an angle of pi fall? Right there. What we do is come up with a coordinate for that point. Like, for example, could negative 1, 0 be that point? Yeah. Now, this is x and y, right? X and y is sine and cosine, right? So, if tangent is sine over cosine, 0 over negative 1, 0. Let me do another one and I'll take a question. Huh? Sine is the x, cosine is the y. Sine is the y, cosine is the x. Okay, now, let's do this one. Cosecant of negative pi. Negative pi is again here. What's a coordinate there? Negative 1, 0. Now, cosecant is the reciprocal of the sine. So the first is cosine, the second is sine. So this is 1 over the sine, undefined. Questions?